So, here's the deal. What you need to understand is this. I'm going to put some stuff up here that I'll say write this down or don't write this down. Again, not to treat you like little kids, but what you need to understand is this. At this point right here, this is the part that you've already filled out, so just watch. I wouldn't do any writing. If it was me, I wouldn't do any writing. I would just watch, okay? What you need to understand is pretend this is like the track, okay? It's the track down by the football field, around the football field. Here's the starting line. You go all the way around, that's one lap. That's 400 meters, we'll pretend, okay? And your coach is standing right here, and he's really, really lazy. And instead of following you along the track, while you're running, he's just going to turn. He's going to stay in the same spot right here. He's just going to turn as you go by. So he's always watching you as you go by. He's going to keep turning like this. So right here, does it say 0 or 360 on yours? 0. 0. Okay. So right here, you're staring straight ahead, 0 degrees. Okay? You're not looking at you at all. Then 30 degrees, what that means is, and again, I told you on Friday, I'll say it again, don't write this. If I connect that, 30 degrees means how far your coach has turned. He's turned, this 30 degrees is actually right here, okay? The reason why I don't put 30 and 60, or 30 and 45 and 60 and 90, because you'd have all these numbers crammed in close, you wouldn't be able to understand any of it, okay? And if I drop this straight down, we have a 30. And if I drop it straight down, or it's supposed to be straight down, 90, that has to be 60 because the three angles of a triangle add up to 180. And then from the special triangles, we learned that on a 30, 60, 90, this distance right here was radical 3 over 2, and this distance right here was a half, and this distance right here was 1. And because it's a unit circle, unit means 1. Distance from here to here is 1. The distance from here to here is 1. From here to here is, it's always 1. You're always 1 away from your coach. 1 whatever, okay? Now, we said on the front of your unit circle, you should have at the very top, you should have cosine is x, sine is y. And the reason is this. We talked about SOHCAHTOA. If I asked you for the sine of 30 degrees, sine is opposite over hypotenuse. Opposite is a half over hypotenuse is 1. A half over 1 is a half. When you divide by 1, nothing happens. If I ask for the cosine of 30 degrees, okay, cosine is adjacent over hypotenuse. Adjacent is next to, so radical 3 over 2 over hypotenuse, which is 1, radical 3 over 2. So, now let's put this on hold for a second here. If I simply did this, if I asked you to name that point, you'd say it's a point 2, 3. Why is it positive 2, positive 3? You went right 2 and up 3. It's not the point 3, 2, it's point 2, 3. How far over you went? How far up you went? How far over did I go to get to this point? I went over this distance, radical 3 over 2. How far up did I go? 1/2. Radical 3 over 2 and 1/2. And these numbers look familiar. This right here is the cosine value. This right here is the sine value. XY is cosine sine. XY is cosine sine. Okay? That's something that if you don't have it memorized right now, it's okay. You need to have it memorized the next 3 or 4 days though, okay? X is cosine, Y is sine, okay? Now, we did the same thing, and I'm going to erase all of this right here, at the next angle, which was 45 degrees on your unit circle. And if I drop that straight down, he's turned 45 degrees now. Well, if that's 45, and that's 90, if it's dropped straight down and forming a perpendicular, that's got to be 45. And then on our unit circle, on our special triangles, this was 1, this is always 1, this is radical 2 over 2, this is radical 2 over 2. So we went over radical 2 over 2 and up radical 2 over 2. So radical 2 over 2, radical 2 over 2. Okay? So the cosine's radical 2 over 2, as is the sine. And then the last one we did on Friday was 60 degrees. Here's 60 degrees on your unit circle. Drop it straight down. And 60 means this is actually 60. He's turned 60 degrees to look at you. You're running around the track. He's turned 60 degrees so you're still right in his vision. That's got to be 30. Because 30, 60, 90 adds up to 180. Well, we showed you that on those triangles. This 30, 60, 30, 90 is the same as 30, 60, 90. They just switched these two. So we're going to switch radical 3 over 2.5. So that's going to be 1/2 radical 3 over 2, or whatever that says there. Okay? And then the last one we did was this. Actually, I think we did this very, very, very end. This doesn't quite fit. The triangle pictures don't always quite fit. And here's why. For example, this says 330 degrees. Are those all labeled? Yeah, 330, okay. 330. How do you draw a right triangle with 330 degree angle in it also? You can't. I mean, it's 180 degrees in a triangle. You'd have to have negative angle measures. That doesn't even make sense, okay? Well, for right now it doesn't, okay? Same with this. How do you draw a 90 degree angle with another 90 degree angle? You can't. That's already 180. The last angle would have to be 0. You can't do that on a flat surface, okay? But we know this is a unit circle, which means this distance is 1. Forget about all this confusing stuff. If you're at 0, 0, and you go up 1, you're at the point 0, 1. Did we actually have that labeled or not? Yes, we did. 0, 1. Okay. And that's where we stopped. That's the hard part, okay? Well, most of the hard part, okay? The very, very last thing we do, and it's not going to be today, is really tough, okay? Now, I would just watch here. And again, we're going to keep working our way around here, okay? Just watch really carefully. If you watch carefully, this next thing is really, really simple. The next one is 120 degrees, okay? Now, how do you draw a right triangle that also has a 120 degree angle? You can't, because 90 degrees plus 120 is already 210. You have to have negative 30 for the last angle, and that don't really make sense, okay? But what I want you to understand is this. I'm going to draw this one back in here. This right here was 1/2. This is radical 3/2, and this was 1. If I do this,
It's just flipped.
what did you just say?
It's flipped.
It's just flipped. I take this dotted one that we just used, and it doesn't look perfect because I'm not a very good drawer, I do the best I can. If I flip this over the y-axis, it's the same one. So, what is this distance right here?
Radical 3/2.
And what is this distance right here?
Half.
A half. Very good. You answered exactly what I asked. Listen very, very, very carefully, okay? I said, what is the distance? The distance is radical 3/2. This distance is 1/2. So, is this right here 1/2 radical 3/2? No. Here's why. We went left a half.
Is it negative?
Why?
Like it's on the left side of the graph?
Is this also going to be negative?
Yeah.
No. Why? One word.
No.
Up. Up is what?
Positive.
Up is positive, but left is negative. So it's not positive. Positive, it's what?
Negative.
Negative positive. Go and put that down. Don't draw the triangles. Again, I'm erasing these triangles anyhow. I'm going to draw one more triangle, and then we're going to be done drawing triangles. If I did 135 degrees, if I connected, and again, what that means is, you ran this far around the track, your coach has turned 90 degrees, he's turned even more. He's turned 135 degrees in order to be able to still look at you. He wants to see how your running form is, okay? You can't draw a triangle, a right triangle, with a 135 degree angle. You can't do it. So, we're going to do this though. And what I want you to understand is, if I was to do this, again, this is supposed to be, it's the 45 ones, it's just flipping them over. It's all you're doing is you're flipping everything over. But instead, so we're going to be looking at radical 2/2, radical 2/2, but instead of positive, it's going to be what? Say it again.
Negative.
Why negative positive? 2 words. Why negative? Left? Up. Left and up. So, negative radical 2/2, radical 2/2. Okay? And at 150, I'm done drawing triangles. Where do you think I'm going to look at to come up with 150 degrees? At 30. Well, instead of positive radical 3/2, positive a half, negative radical 3/2, positive half, because it's still left and up. Yes, sir?
So wouldn't a good way to explain it, just because this is a graph, it's just the quadrants of a graph?
Say it one more time.
So because this is a graph, like example, it's just quadrants of a graph, top right is positive,
Plus,
left.
minus positive, minus, plus, minus. Yep, exactly. Yeah, you got to know that. If you know that, piece of cake. So, this one right here, we're at 180 degrees. Your coach has turned halfway around, okay? And again, this one right here, you went left 1, because it's a unit circle, left 1 and up none. So it's -1, 0. Okay, I'm going to fill these in 210. What do we have here? 225, 240, 270, 300, 215, 330. Okay, so to get 210, here's what I'm going to do. Just like we flipped these over the first into the second, I'm going to do second down to the third. But instead of minus plus, they're going to be what?
Minus, minus.
Why minus minus? Two words.
Down.
I would rather say left down, but we'll take it. Okay, so you always go left and right first, then down, up and down. So down or left and down. So where am I going to look at for 210?
150.
150. It's going to be negative radical 3 over 2, negative 1/2. Where are we going to look at for 225? 135. It's going to be negative radical 2 over 2, negative radical 2 over 2. And 240, we're going to look at 120. Negative 1/2, negative radical 3 over 2. What's 270 going to be? What? Well, but what though? This one right here. What's the point? What? 0, negative 1. You go left and right, none. You always start at 0, 0, just like plotting points way back in middle school. You go left and right, none. You go down to 1. So 0, negative 1. Okay? How about these three? They're going to be what? Positive? Positive, positive? Positive, negative. Why? Two words. Right down. Okay? Now, here's what I could do. I could flip over quadrant 3, or I could flip 1 down to 4. It doesn't matter. It really doesn't matter. I'm going to go flip 1 and down into 4. In case you forgot your quadrants. This is quadrant 1, 2, 3, 4. So, if I'm doing 300, if I'm looking up here, where am I going to look at for 300? Which row? 60. Well, instead of positive 1/2, positive radical 3 over 2, it's going to be positive 1/2, negative radical 3 over 2. Where's 315 going to come from? 45. It's going to be radical 2 over 2, negative radical 2 over 2. In 330, we're going to look at 30, radical 3 over 2, negative 1/2. Again, why was it positive, negative? Because it was what? Right and down. And then this one, I don't know if we ever filled this one in right here. You simply go 1 to the right, you're what? 1, 0.
And that's not concept of 0 and 360?
0, 360, yeah. It's when you fill it in on either one, I don't care. Okay? Because right here, I tell you what, if I went down to the track right now and I saw a kid standing on the track and the coach sitting right here staring at him, how far, and you went down there and you just saw him, how far has the kid ran? Has he ran 0 degrees or 300, or has he gone all the way around?
You don't know.
You don't know, unless, if he's all sweaty, maybe he's already ran, but if he's, it's hard to tell. I would take either one though, okay? Now, on your unit circle, it says x is cosine, y is sine. Now, if you're sitting here going, oh, we're done? No, we're not, okay? But this is what I want to make sure you understand, okay? If I was to ask you this, okay? If I was to ask you what is the cosine of 240 degrees? What is the cosine of 240 degrees? Heard somebody say it, what? How'd you get negative 1/2? What'd you do? 240 degrees, and cosine's the what value? X, negative 1/2. So, if you were to grab a calculator and type in the cosine of 240 degrees, it's a negative 0.5.
Is that what you said? We look at this a lot.
You're going to look at this a ton over the next month or so. Okay? How about this? How about the sine of 315 degrees?
Negative radical 2 over 2.
You go to 315 degrees, sine's what? The first or second value? Second, negative radical 2 over 2. And again, the calculator's not going to say negative radical 2 over 2. It's going to say like negative 0.707 or something like that. I'm not sure. It's going to round it off to a decimal. But these are exact answers. Okay? And that's what I want, are exact answers. If I ask you on a test, what is the sine of 315 degrees, and you say negative 0.707, you know what I immediately know you did? You use a calculator. That's not what, if I just said use a calculator, I'd say, don't worry about this. Okay, we want exact answers, okay? All right, now, next thing we need to talk about is this. We've done sine, we've done cosine. We got to do tangent, okay? Flip your sheet over for a second. Tangent, you have opposite over adjacent. I also want you to put down this. It also equals sine over cosine. Write that down. And I'm going to prove it to you. You don't need to write this part down, okay? Here's how I could prove it to you. I think I showed you guys this in algebra 2, maybe not. Without a calculator, can anybody simplify this for me? 4/5 divided by 7/5. I don't know if I showed you this or not. Anybody know what 4/5 over 7/5 simplifies to? I never showed it to you. It simplifies to 4/7. I didn't tell you why yet. I'm going to do maybe one or two more examples, and somebody's going to explain this little shortcut you can use.
I feel
If
like
I gave you 3/11 over 5/11, that's 3/5.
yeah, you just take the top.
When can you do that? You just cross off the denominators whenever you want?
No.
When they're the same. When they're the same, you can cross them out. Okay? Now, if I gave you 2/3 over 3/7, you can't do that because the denominator is one denominator is 3, one denominator is 7. You can't do that. Okay? So, here's why it works. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Simplify O over H over A over H.
Oh, right.
O over A. What's O over A? Tangent. Tangent is opposite over adjacent, which is also sine over cosine. Okay? So, tangent is sine over cosine. So, it goes cosine, sine. Out here, we're going to put the tangents. Okay? So, how do you find tangent? Sine over cosine. What's the sign here?
A half.
A half over
Radical 3 over 2.
radical 3 over 2.
So this would be a half over radical 3. But you
Now
can't
clean
do
that up. I just showed you a little trick.
1 over radical 3.
Be quiet, I know you're going to say it. Cross off the 2's, 1 over radical 3. Say it now.
You can't have it.
You can't have radicals on bottom, so we're going to times the top and the bottom by radical 3. 1 times radical 3 is radical 3. What's radical 3 times radical 3? Radical 9, which is 3. So, before I write it down, what's radical 3 over 3? Don't tell me, I'm not asking you to calculate it. What is radical 3 over 3? What did we just find? The what? Tangent of what? Angle.
30 degrees.
So out here, put radical 3 over 3 and circle it. It goes cosine sine in parentheses, and then the circled number is going to be the tangent. Let's work our way around. Tangent's not going to take long at all. What's the tangent at 45? You should be able to do this one in your head. What's sine over cosine? What's radical 2 over 2 over radical 2 over 2? 1. Why? Describe these. What happens when you divide something by itself? What's 1? The tangent of what? 45. Now, at 60, here's what we could do. We could flip this answer. Because remember we just flip-flopped these? We could just flip this. But instead of, if I flip this, you see what's the problem we're going to have?
You're gonna get this right.
You have radical on bottom. But back here, I'm going to flip this. That way I won't have a radical on bottom. What's 1 over radical 3 flipped? Radical 3 over 1, which is? Let me ask you this. What's a positive divided by a positive? Positive. What's a negative divided by a negative? Positive. What's a positive divided by a negative? Negative. What could you say, forget about this one for right now, ignore this for right now. What could you say about the tangents here?
They're gonna be negative.
Why?
Because it's negative times positive.
One's negative, one's positive. Okay? So for 120, we're going to look to where over here?
60.
60. Here it's radical 3. Here it's going to be what?
Negative.
Negative radical 3. What's 135 going to be?
Negative.
1, but negative. And what's 150 going to be? Negative root 3 over 3. Ignore this one for right now. We'll come back to this in a minute. Okay? Are these going to be positive or are they going to be negative? Positive. Why? A negative is positive. So, this one we're going to look to what? 210, we're going to look at what angle?
30.
I like to look at these ones. I like to fold these over. 150. So it's going to be positive radical 3 over 3, positive 1, positive radical 3. I hammered through those fast. I want to make sure you got that. I just flipped these down, but instead of making them negative, they're going to be positive. How about over here? Positive or negative over there? Why? One's positive, one's negative. So 300, I'm going to look up here at 60. It's going to be negative radical 3. For 315, we're going to look at 45. It's going to be negative 1. And at 330, we're going to look at 30. It's going to be negative radical 3 over 3. What are these circled numbers? They are the tangents. Okay, so while you're filling that in, answer this for me. What's the tangent at 225 degrees? 1. This is what I'm talking about. We spend all this time, and then you're gonna show. If I ask you that on a test, you're gonna show me work on that? No. You look at the unit circle, you write it down. Okay. How about the tangent of 135? Negative 1. Okay. All right. We got well. We have to figure out these ones up here. Here, this one's not that bad. Take sine divided by cosine. Sine is what? 0 divided by 1, which is 0. Up here, what's sine divided by cosine here? What's 1 divided by 0? Why is 1 divided by 0? You guys said it's 1? Is that what you said? Or you said it was 0? Tell you what, 10 divided by 2 is 5, because 2 times 5 is 10. How come 1 divided by 0 is not 0? Because 0
You can't have 0.
times 0. 0 times what gives you 1? Nothing. You can't divide by, remember that's undefined. You cannot divide by 0, okay? Even 0 divided by 0 is not 0. Think about it this way. Can you make 1 out of 0 free throws? No. Can you make 0 out of 1 free throws? Sure. You open, you miss. You're 0 for 1. You can't make 1 out of 0 free throws. Now, how about this? I'll try to use this example. If you're 0 out of 0, are you a good free throw shooter or are you a bad free throw shooter?
Neither.
You're not a free throw shooter. Okay? You haven't shot one. Okay? 0 divided by 0 is undefined. So, what do I put up here?
Undefined.
If you type in the tangent of 90 on a calculator, you know what the calculator says?
Error.
Error. You're asking for a number that doesn't exist. Okay? How about over here? What's the tangent of 180? 0 divided by negative 1 is 0. Now if you go, well, how do you make 0 out of negative 1 free throws? Well, that analogy doesn't really fit. So I use it when I can. How about down here?
Negative undefined.
You don't say negative undefined.
I say
You can say it, it's just undefined. It's not a number. Don't put 0, because that's not. It's not a number. Okay? Okay.
There's a lot of stuff on the chart.
Now, before I go any further, okay? Again, you know what would have been a whole lot easier for me and most college professors would do? They say, if I just said, if you would have came in here the very first day and I gave you a sheet and it had all this on it and said memorize it, what would you do? I don't want you to memorize it. In all honesty, you need to memorize this, you need to memorize this. And this one's easy because they're the same, okay? How'd you get this?
That's Latin.
Flipped it. And then how do we get these? Flip them over, flip them over, flip them over. And then how do we get the tangent? 3 words. Still on the board.
Sine over.
Sine over cosine. As long as you know tangent, sine over cosine. I don't want you to memorize it, I just want you to understand it, okay? All right, we got one more thing to talk about. And this is the part students hate, absolutely hate it, okay? And I'm going to do this. For people that are at home, I'm going to explain this again tomorrow because I feel nothing personally. You guys, my thing keeps freezing up on me, so I want to stop this. It's still recording right now, so I want to stop this before it freezes up.